Alright, so for this video I'm going to be doing it on my other computer, so I'm not going to be drawing or writing so much. The idea here today is that we're going to be talking a little bit more about regression. And when we're done with regression today, we're going to obviously have y equals, you can call it mx plus b, ax plus b, whatever turns you on. We're going to get some equation like this, and we're going to get an estimate out of this thing. Okay, so I plug in an x, I get out a y. That's a predicted value. And what can happen then is we can make a confidence interval for that prediction. Now that is a mess to do. I'll just tell you right now, it's not the prettiest formula. Now you're going to want to reference it, and that's on page. I'm going to look it up for you here and tell you exactly where it's at. If I can find it now. Yeah, so, right, there it is. So on page 539, about halfway down the page, you will see something that looks a little like this. It says E equals, big E though, big E equals T sub alpha over 2, which we'll talk about, times the standard error, so it's S with a little E by it, and then times the square root of all that mess. Now, we're going to work on that today, and we're going to kind of walk through that mess. And I'll probably do an extra video piece to this where I talk about that some more. And so that'll be kind of important to do. Now, a couple of things we're going to talk about today, of course, are, well, how to do all this. But then also, once I see it, and it's not that hard to do, but once I see that thing, then what am I going to do about it? And so this standard error, that's going to come up in some of the calculations that we do. T is just an inverse T like we've been doing all along. And this is going to be what's called our margin of error. So we're just going to be able to take and add this error plus and minus from our particular value that we're going to predict for. Okay? So really what it's going to boil down to is we're going to get a y hat, a predicted value, and we're going to subtract the error from it. And we're going to go on the other side, we're going to go, well, here's our y hat, our predicted value. We're going to add this margin of error to it. Okay, that's it. So that's the key tonight. We're going to run through the whole regression bit on every problem. It's going to be the same basic thing. What I'm going to do on this video is, at the end of the video tonight, or at the end of this video, I'm going to write out on paper, write out on another deal on my tablet how to write out the entire equation piece. But we'll see it. I'll do the math on here in the computer. You'll see it just fine. But I'll actually write it out, a little more handwriting, a little more bigger piece of it, so you can follow along, hopefully, if we need to. Pause for just a second. Alright, so the idea here is I just want to run through several of these guys so you can get the hang of it. So once again, I want you to use, for this lesson today, and pretty much all the regression, I prefer you use the regression tabulator in here. So I'm going to go highlight my Y range. Oops, my Y range always first, that's important. Then your X range. Make sure you check labels. I always like to have my residual plots. I don't necessarily have to have my residuals pop up. I need my residual plots to show up. Here's my residual plot. Now, you'll notice I was a little lax in that I probably should have, right off the bat, gone ahead and put in my scatter plot. And there it is. And you can see it's nice and linear. Everyone's happy about that. It's going to be a nice straight line. But what this residual plot is showing me is that in the middle I'm going to be over estimating, and on the outside I'm going to be underestimating. Okay, just so you're aware of that. Okay, so we're going to be underestimating out here, and we're going to be overestimating in the middle. I think that's what I said. Now, what you want to look at when you do this chart, and this chart's going to come up, there's going to be about 18 things on this chart that are going to be a big deal for us. Okay, obviously R is huge. Literally, in this case, and it's always a big deal. R squared is always huge. That also is a big deal. Okay. The standard error, that's that SE I showed you a minute ago about. Okay, that is going to be a huge deal for us coming up. Okay. Then you're going to flash your eyeballs over here, and you're going to look at this number here. Okay. Honestly, my eyes go boom, boom, boom. So I took up this r on r squared on my way to here. This tells me this is less than 0.05. So the regression is significant. We don't have to do a test anymore, that t-test. This is a big deal. We know that it is significant because this f is so small. Again, if you were cared about it, the t that you'd be actually finding, this is the f right here, that the square root of that fella is this 30 right here. Okay? So it'd be the same, and that would be the p-value right here is the same as that p-value right there. So it is significant, and that means that there is a significant correlation. That means that I can write an equation from which I'm going to do it. And so my next things I'm going to look at are literally right here. Boom. Okay? And you can again make these wider. These are your coefficients. And so it becomes y equals, I'll write it right here, and it becomes, and now I'm going to write it like this, 9.0138 or whatever, as many decimal places as you want, times year minus 17624.25 or whatever. Okay? This is our regression equation. That is what would happen if you came over here and get, hey, I want a residual, I want a trend line, I'd like it to be linear, show me the equation, show me the r squared. Oh my word, it's literally the same. Who saw that coming? Everybody. So there's that. Now, that is a big deal, okay? Because what's going to happen now is now I can actually use this to predict, which we know that's not that big a deal. So I'm just going to say it's 9 point whatever times the year. Now you're like, well, what year do you want to use, Jay? And I'm like, well, I don't know. Let's predict for 1976, let's say. So let's just times it by 1976. And then I'm going to take minus this fella, or I'm not going to minus, I'm actually going to hit plus because I'm just going to click on it and it's already negative. And so therefore I would be in 1976, I'd be predicting for 187. Well, if you come over here, as you see, we're just a little high, yes? And that's exactly what we thought would happen. Look at our line. Our line here is coming through here. And in 1976, it looks like we're going to be predicting down up into here. And we actually had a value at 76 that was below the, see where's 76 at, right? Which one is the line? 76. 76 is right here. So you can see in 1976, it was 178, which is below the line. So our estimate, being on the line, is greater than it. And so we're overestimating down here. We're also overestimating up on the top end, but we're underestimating through the middle. That again is what our residual plot is telling us. We're underestimating here, and we're overestimating on the ends. Okay? Now, what I'd like to know is, can you give me a confidence interval for this thing? I'm going to pause for just a moment and bring the formula up in a picture so we can see it. All right, so here's the formula. It's y hat plus or minus. Now we're going to need a t. Now this particular picture here that I copied from somebody else's, thing, shows S sub y, but that's what's called the standard error. And I'm going to show you, we already just Googled where that was on our cheat sheet there. This is, oh crap, just a minute. Don't pay attention to this one. Don't pay attention to J. Alright, back with you. So I wrote it out. It's really hard to draw on this thing without a pen, but there it is. So, again, so we're going to take half of alpha. So you're like, well, it's a 90% confidence interval, let's say. I was doing 90%, that leaves 10% on the outside. So then we're going to take half of that, put half in the lower tail and half in the upper tail. So 5 and 5. Standard error, we know where it is. N is the number of pairs there are. So everywhere there's an N, that's what that means. X naught is the number in question for that we predicted for. In this case, 1976. Wait a minute. You mean for 78 it'll be different? Yeah, that's right. So this is the mean of the x column, which we're going to figure out in a moment. The sum of the x squared, sum of the x column. So you're going to take the numbers in the x column, square them, and then add them together. And then this is the sum of the x's, and then we're going to square that value there. Now we're going to do this together. I'm going to pause for just a moment, get everything set up, and then we're going to do it boom, 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 done. Alright, so we need to find the sum of the x's. So the easy way to do it is to go equals sum. Okay, parentheses. And then we'll click and drag these guys. So this is the sum of the x's. Okay? And then we also need to find the sum of the x's squared. So to do that, there's probably the easiest way. The easiest way is probably just to go equals and click on the x over here, squared. Okay, copy that down like so. And then take up here and then do something like this, goes equals the sum of these columns. I'm going to say it's the only way. I'm saying it's a pretty easy way to do it. Okay, so I'm going to copy those two numbers. And when you copy between sheets, it's always a good idea to, when you paste just the numbers. So this is sum of x, and this is sum of x squared, right? So this is where we keep track of that. So let's look at the recipe. So we need to go find a t value for this. So we're going to do inverse t, so equals t dot inverse of 0.05. Remember, this is 2 degrees of freedom on this deal, right? So our observations were 25, so we want 23 degrees of freedom. And voila, negative 1.71. So you start looking at this, we have our recipe. So we have our t value, boom. We've got this guy, boom. We've got this. We've got everything we need to make this sucker cook. So let's see if we can make it happen. Okay? So, if I can find my cursor, oh, there it went. Okay? So, if you're playing along at home, we've got this guy. We've got this guy. Okay, we got our sum of x's, sum of x squares, and all that good stuff. So it's going to go like this. It's going to equals this guy times standard error, cool, times the square root, SQRT. Now this is all doing it in Excel. You are more than welcome to do it on your calculator instead if you like. So 1 divided by 25, right? Plus, now I need the top of that fraction. So, the top of the fraction is parentheses. Now I want everything to be up on the top of that fraction. So I'm going to go parentheses. I'm going to do n again times parentheses again 1976 because that's what we predicted for, right? Oops. Minus the average, which I never wrote down yet. So I'm just going to put a number there for right now. Crap. I'm just going to put the number 2 because I don't know what it is right now. I'll come back to that in a minute, okay? So that's my numerator divided by my denominator. So parentheses, and then come back down and look at our recipe again. We're going to take n times the sum of the x squareds. So that's cool. So we're going to take 25. It'd be nice if you actually clicked it, dummy. Times the sum of the x squareds, boom, minus the sum of the x's. Oops, what are you doing, stupid? Ah, squared. A boom. And I'm going to hit enter, and it's going to be disgusting and doesn't even make any sense. So watch me come back over here to the previous page, and I forgot to hit equals average. Equals average. Uh-oh, I didn't spell it right apparently. Equals average of the x values. And it's 1983. So come back into here, and where I put that, oh shoot, where did I put it? Where I put that placeholder in there for the 2, put 1983 instead, okay? Ta-da! So notice 3.44. Okay? And the reason it's negative is because I used the negative right there. You see this deal? Shouldn't have done that. So let me just back that off. So I'm just going to change this. Well, I'm going to make that. I guess I'll just make it a negative. It doesn't really make any difference. So 3.4. What that means is then is that my confidence interval is equals this guy minus 3.44 on the bottom end, and on the top end, this guy, oops, shoot, equals this guy plus 3.44. And so we are pretty confident that y in 1976 is in between here. How confident are we? Yeah, we're 95 or 90% confident. And that's our first one. The next one's going to go a little faster. Alright, here's another set of data. Distance between your eyes and IQ. Geez, I wonder if there's any correlation there. Okay, so I highlight them again. Come over to here. go to regression just for good times. Hit OK. Oh, before we do that, you know what? Before we do that, I'm just going to do what I normally do, which is let's make a graph of this mess, see what happens. Because, you know, if it's not even possible... Whoa, holy cow, who saw that coming? Interesting. Interesting. Sure looks like there might be a correlation there. So, once again, go to the Data tab. Go to Data Analysis. A little regression. Again, always highlight your Y's first. Alright, then go get your X's. That's right. There we go. Boom. Okay, make sure you got the 1. Make sure you get the labels on. I'm going to put the output range in this tab this time because, well, I don't want to keep going back and forth. So I'm going to kick it over here somewhere. Boom. Boom, there they are. Again, make this thing so you can read it, and let's go highlight the stuff that we're interested in. So I'm interested in R and R squared, so I'm going to highlight them. I don't know, maybe I can't. Maybe I can't pay attention too good unless it's highlighted, so I just do it. Again, that's a big deal to me. What the significance level is. Boom, these guys are huge to me. Boom, and away we go. So clearly, it is totally a significant event. Now look at this thing here. It's completely significant. It's less than our 0.05 or whatever. It doesn't even matter really what we put it in as, but 0.05 is usually, as I say, the default. But it's clearly less than anything we'd ever ask you about. So yeah, it clearly is a strong correlation. Our equation then would be y equals, and I'm going to put in 8.29. I'm just going to write 8.29 times the distance, all right, plus 86.7. Where's the point there? Ugh. And there it is. That would give me a nice prediction for my IQ, which is pretty weird. Kind of seems like someone with a big, you know, with walleye-sized eyes when they're looking out for the size. That'd be a zillionaire, genius-wise, but I don't know. So, what I want to do then is, again, I want to predict for this thing. So, again, come back over here. Let's look what we need. We need n. Hey, we got n. I forgot to highlight it. We have n. Boom, it's right there. It's 12. Okay, that's a big deal. Now, we got the numbers. They're still here. So, let's talk about what our numbers are. We need to have our x's. We need the sum of the x's. So it's from here to 13. Boom, done. Shoot, done. And then I need to have the x squared. So I just go over here and just go x squared. Drag it down like so. Come over here somewhere. It doesn't matter where you do it. Equals sum of those x's. Boom. And then let's go find our average, because we'll need that in a minute too. Boom. Done. Okay. So now we're good to go. I'm going to copy those, drag them over here a little closer to where I'm working. So I'm just going to do it over here where there's a little more clean air to work. Paste those values again, just so I don't forget. Sum x, sum x squared, and standard error. Or not, average rather. Okay. Cool. So the formula is I need the inverse t, right? So let's say it was a 95% confidence interval. And for the most part, that's what we're going to do. So we're going to put 0.025 and then 10 degrees of freedom because it's always 2 less than our observation. So I'm going to go 2.28. So I'm just going to put a negative in front of that. I keep forgetting to do that the right way, but whatever. So then my confidence interval is equals the t times the standard error, okay, times the square root, okay, of 1 divided by n, plus, I need an open parentheses, that gives me the top. I'm going to take n times parentheses, okay, and then I'm going to predict for a value. Now, I didn't tell you to predict for anything this time, but let's predict for like, I don't know, let's see, what do you think? Let's predict for like 1.5 centimeters or something there, okay? I feel like 1.5 is a good amount to do for. I'm going to do 1.5 minus the average, boom, like so. And remember, that is squared, so don't forget to square that, okay? Again, the formula is right here, okay? Now, as soon as I square that, I'm going to close the top of that. That's the top of the top of the fraction. Now, divided by parentheses. Okay, and then what does it want down there? We want n times the sum of the x squareds minus the sum of the x's squared. Close the bottom of the parentheses, close the whole square root, and we're done. So what we're saying is this: we need to actually predict. So it's equals 8 point whatever times. Now we said we were predicting for 1.5 centimeters. Cool. Plus this amount. This is my initial value. So my confidence interval is this minus this, and it's equals this plus this. Boom. Done. What? And there you have it, friends. The 95% confidence interval for that prediction. Alright, one more. Start to finish. See if we can do it as fast as we can. This is your age, your mom's age. Well, your age a long time ago. I don't know. Boom. Boom. What? That looks pretty linear. Alright, let me drag this thing down here out of the way. Alright, now let's go and let's get our data tab. Data analysis, little regression action. Highlight your Y's. Whee! Let's go get your X's. Booyah. And we're done. And, oh. No, I did it right. I was like, oh no, I put it on the wrong page, but I didn't. It's right there. Cool. Again, drag these babies out where you want them so you can read them properly and whatnot. But, hey, the biggies are. Get your pen, let's go to highlighting. Boom. Oh, fart. Let's don't highlight that. Okay. There we go. It's been a long week, friends. Hey, those are big deals. Oh, for God's sakes. I can't even run a highlighter tonight. It's time to go to bed. Whee! Those are kind of important. This is important. And if that's important, these are important. By the way, excuse me. By the way, if this isn't important, this is not important. Nor is any of this garbage. Okay? Okay, so I want to know about my x's. So I'm going to equal sum of my x's. Boom. And I want to do the sum of the x squared. So I'm going to just go over here and go equals x squared. Boom. I'm going to say equals sum of those guys. And I'm going to say equals average while I'm here. Again, always of the x's. And I'm going to choose a value to predict for. I'm going to predict for 15, I guess, just because I feel like it. So grab these guys. Okay, bring them over here. There's a little more room to work. And again, paste special. Paste values. Okay, so once we got that down, again, we want to predict for some value. So I said let's predict for x equals 15. Voila. I need t inverse, so equals t dot inverse. And again, let's just stick with our 95%. By the way, if you're smart here, which I rarely am accused of that, you could also put in 0.975. That would give you the upper tail, so it would already be positive, so you wouldn't have to do anything else. So I think that's what I'm going to do. And 8 degrees of freedom. So our formula is equals t, okay, times the standard error, boom, times the square root of 1 divided by n. What? Plus parentheses. And then we want n times parentheses. And we want the predicted value, so 15 minus x average, which was 15.2 squared. And then divided by parentheses. Then we want n times the sum of the x squared minus the sum of the x's squared. Bam! There it is, friends. And so our predicted value, which we don't have yet, which I'm going to do right here, is equals 1.96 times 15. Again, that's the one we wanted to predict for. If it was a different value, just put a different value in. And so our confidence interval would be this 37 minus 2.6. That's the one I want. Yep. And then over here, it would be equals this guy, a plus 2.6. Ta-da! We're done. Feel pretty good about that. I'm